plus x5. So this is in your formula booklet anyway, so you will never be asked, I'll say never, they might ask, show that it equals this. It's possible they ask, show that the Maclaurin series for sine x is that. Turning that into a sequence then, or a series, the idea is we always start with this for these type of series, for the k is equal to 0 for the reason. You can do 1, but it's better to do 0. Right, so how do I get this? I know there's going to be x in each term. It's x to the power of something divided by something factorial, isn't it? Maybe I want to put the 1 factorial here if I want, and x to the power of 1 here might help me with what each term is. And I know that it changes from positive to negative signs. So first of all, how do I get odd powers? If I sub in 0 into the first one, how do I get odd powers? Well, odd, you think 2k minus 1 or 2k plus 1 will give you odd numbers. If you put into this, that's going to give you minus 1 as the first term. So we use this if we're using 0. If you're using 1, you can use that. If you're using 0, use this. So the power is 2k plus 1. So when I sub in 0, I get 1. When I sub in 1, I get 3. When I sub in 2, I get 5, and so on. So I double and add 1. That gives me odd. The same thing is matched here. So that's going to have to be 2k plus 1 factorial as well. I would put that in brackets in a second. And then how do I switch? Every second one is negative. That's going to be some multiplication of minus 1. What the power then needs to be is, well, is the first one, if I put, let's just try k, will that give a positive for the first one? If I sub in 0, yes. Oh, yeah. If I sub in 0, I get positive. Anything to the power of 0 is positive 1. And then does it give a negative for the second one? Yes, the power of 1 then gives minus 1. So that'll swap it every time the way I want. If that wasn't working, I put k plus 1, and then that would swap it the other way. The first one then would be negative, and then positive, negative, positive, if it was okay. So you wouldn't write it here with the box, obviously. You would write minus 1 to the power of k, x to the power of 2k plus 1, all over 2k plus 1 factorial. Hello. And then that's how I write that, to turn a sequence into a series. Okay? Bye. All right. Okay. So you've been given a bunch of these and in your formula booklet. So how are we going to, I don't know if that's, yeah, it's here. No, yeah, so like that. So we have to be able to use these and manipulate these. So let's look at a couple of questions.
I actually got that when I crossed it out.
You got this?
I crossed almost.
Oh.
2k plus 1.
Oh. Throwing away. You could have got 10 points. All right. So let's look at this. So this one isn't one that's in the formula, but I'm going to have to double check. I don't think it's the one. I think there's, no, just to make it sure. This is not one given, but they do give this series. They do say, right, the Maclaurin series for this, so its expansion is this, starting at 0, minus 1k. Now this should look a little bit easier than now that you've thought about it a little bit more. Is that 2 to the power of k plus 1? That's not factorial, it's just x to the power k. Okay, this isn't confusing terminology, hopefully, anymore. You could have a quick look what this sequence is going to look like. What's the series going to look like if we did it out? What's the first term?
1 over 2.
So remember, you're subbing in 0. So that's going to be 1. This is going to go to 1 as well, and this is going to be 2 to the power. So it's going to be a half. Yeah, you happy with that? 1 over 2. What's the second term in this series going to be? Is it plus or minus? Yeah. Minus. So you're subbing. What you're doing is subbing in 1 here. So that's negative 1. It's going to have an x in it, isn't it?
4x. X over 4.
X over 4. Yeah. And the next term?
X squared over 8. Negative.
Very good. And we're all of a sudden, okay, we've cracked the code. We were able to, where are you getting? Oh, we did this yesterday, did we? Yeah. pretty good. But you'll be able to get it pretty quickly. Once you get the feel for it, a bit like this one, once you get the feel for it, it was like I could do it forever. So that's fine. All right, so that is what that translates to, but how will I get the Maclaurin series for 1 over 2 plus x squared? Is it plus as well? Minus x squared. Okay. How will I get that using this?
Change the minus.
Yeah, maybe, yeah. Yeah, it is. It's going to be substitution in. What do you think we're going to substitute in? So if I sub in, instead of x, I sub in x squared, will I get the right answer?
No.
Don't think so. Will I? No, yeah, so these are you can sub in, you just got to sub in the right thing. Substitute in to change the x.
We have no idea.
I know, yeah, okay.
So just tell us.
What's the difference between the two? What's the difference between the two?
It's times negative x.
Okay, so
Plus 2x.
what could I replace this in this series, considering this uses just x? How could I rewrite this if I want to just replace that with this? All right, let's keep it the same. Let's just keep it plus. What would you do? Let's just keep it plus.
X. Oh, times x.
Oh, x is there. Times
You can multiply everything by x.
square everything.
K plus 1.
So instead of x, it's now x. Is it x squared here?
Isn't it x minus 1?
You can literally substitute everywhere there's an x here. Substitute x squared.
Okay.
Oh.
That's literally what you could do. 1 over 2 minus x squared over 4 plus x4 over 8 minus x6 over 16.
That's pretty easy. Yeah, we
It's
knew
this-
that.
It's the same, yeah. It's the same. So I was saying, we can substitute into these series. If x is, in this one, if it's sine 2x, that series could be written, 2x over 1 factorial minus, 2x cubed over 3 factorial. It is that simple, yeah. It is. It's the exact same thing. Plus 2x. So that's why these are given to us, because we can substitute into them and find even more difficult, because they're like the base function of the base Maclaurin series. We can substitute into them to find even more difficult
Wait,
ones.
so for like if it was inside of it was if it was like sine x plus 1.
Now, what this is going to get more difficult. So let's say if we want to find a polynomial where we're going to do a more difficult one in a second. You're going to see, you see this one, where it's e to the x subbed in for cosine x. So it's no longer like a polynomial, a composite, like just an x function subbed in, a normal x polynomial function. It's an e to the x, which in itself is a Maclaurin series. So this one, we're going to end up substituting a Maclaurin series into a Maclaurin series. But we're going to look at how simple it is if it's just... We'll get to it. We'll do this one next, actually, because it might suit my point better. How simple it is to just replace, if it's a polynomial, so just an x function. We'll look at how simple it is, but then we'll look at how difficult it is if it's a double Maclaurin.
Yeah.
So let's look at a simple example. First, keep it on...
For this first one, do you just multiply it by negative term?
Yeah. So let's look at the...
So it's just negative a half x squared.
You're going to have to change. Every second one's going to be negative. All right, let's do this one. So if I was faced with this in exam, it's a Maclaurin series with e to the x. I go to my formula booklet. I go, what is the Maclaurin expansion for e to the x? I don't have to do it out. They have it for me. What is it?
1 plus x squared over 2 factorial.
Okay, plus x cubed over 3 factorial, so on. I have that. So what does e to the 2x then look like? It means everywhere there was an x here, I replace it with 2x. Very good. 2x plus 2x to be squared over 2 factorial. Now remember that would be 4x squared plus 2x to be cubed over 3 factorial and so on. So that is the same. You can, So it'd be, whatever, 8x cubed. Yeah. And then we have e to the 4x, the same thing happens. So it's very easy to substitute into one of these polynomial functions. So if you're replacing 1x, it's the same with like a transformation or a composite function, f of x into g of x. You just replace whatever x was with this new function. Yeah? So you're just doing that multiple times. So when you do f after g of x, you take the g function, you sub it into the f. It's the exact same we're doing here. Just for every x, we replace it with what the new thing is. Okay, very good, no problem. What happens when it's any value of, so e to the nx? Well, it's just 1 plus nx plus n. If you want to multiply it out, you can go n squared x squared over 2 factorial plus n cubed x cubed over 3 factorial. So on. Not too bad. So that's composite function. We sub one into the other. Just a normal polynomial into the other one. Right. Now use the Maclaurin series expansion for cosine x to find the first two non-zero terms of this.
Wait, sir.
I'm on to part B, yeah.
Yeah, no, but why is the Maclaurin series for EX? Why doesn't it have any EX in it?
Good question. What's the whole point of a Maclaurin series? The whole point of a Maclaurin series is to turn a non-polynomial function into a polynomial.
Oh, because it's e to the power of 0, so it's 1.
Yeah, I didn't think about that.
Just
Okay.
think about that.
Just say yes.
Okay.
It's zero.
So it uses matching derivatives to the original function to create a new function.
No, I get that. It's like I was
Okay.
thinking like why? Because the function is e to the x.
Oh, at 0, it would have to match. Yes. Okay. Yeah.
Yeah.
Yeah, I understand. Yeah. All right. So, what's the expansion for cosine x, first of all? From formula booklet again. We did it yesterday. It's the 1 minus x squared over 2 factorial plus, it's the even one, whereas sine is the odd one, isn't it?
Yeah.
Like 6 over 6 factorial. Okay. Use that to get the for cosine e to the x. Now, if I want to turn this into a polynomial, it means e to the x can't be in it either. So everywhere there's an e to the x, I have to sub in its own Maclaurin series.
What? Yeah.
Now,
So
so
for the
remember, all